Hello, my name is Steve Wood. What you're going to see here is a ninth grade physics class for Gann. What we're doing in this class is actually a second day of a lab. On the first day, they went into their homes and explored a couple of questions about what happens when they look into mirrors. This is to study the phenomenon of reflection, to have them take their own data and observations and make it into explanations of why the world works the way it does. Hope you enjoy.
Hi, everybody. Great to see you.
Hi, Mr. Wood.
Hello.
What's up?
Doing good. So let's get started. So what you had for your homework was to take the data for the at-home mirror lab. And you didn't have to worry about why it worked, but I wanted you to work on like getting the data for those two experiments looking at the mirror. So what we're going to do to start is talk a little bit about how the data went, any questions you have for those first two, particularly the first one, because the first one is actually something people have a misconception with and often take data they think is right and actually is not. So on that note, what did people end up getting in general for when you did the first question, not the second, but just the first? What did people find when you were going different distances from a mirror, like what you saw of yourself? So people, what I want you to do, you can raise your hand, but also just put a dot in the chat so I can see. So I'll start with Sadie. So Sadie,
Okay.
yeah.
I don't know if I did this correctly, but I got that like you could see the same amount each time.
Okay. So
Did I do that?
we're not going to say whether it's right or not yet. We're going to hear what everybody says, then we'll look at things. So what about other people? So Danica?
For me, as I moved farther away from my mirror, I could see more.
Okay, so we have somebody so you could see more of yourself. Was it a lot more or a little bit more?
No, it was like going from like 3 inches by like 5 inches to like 3.5 by like 6 inches.
Okay, so a little bit more, but not a lot more.
Yeah.
Okay, so Jonah?
I saw like the same amount of myself, but like the rest of the background, like the total mirror, like a certain amount of it was filled by depending on how far back I went.
Okay, so Ellie?
I saw less of myself, but I also just might have put the mirror too high up. So.
Okay, so you saw less of yourself as you went away or got closer?
As I went away, I saw less of myself. Okay. But I think maybe the mirror was too high up because I just started seeing the top of my head.
And that's it? Yeah. It also might be the mirror can be angled, and even a subtle angle can make differences that way. So Jeremy?
I saw the same amount of myself even when I moved back. I saw like the same image.
Okay. Caleb?
I saw the same amount as I went back. Yeah.
Okay. Okay. Eli?
I also just saw the same amount.
Okay. Abigail?
Yeah, I saw the same amount, but I'd see different things.
Yeah. So people made good observations here. So what it should work out to is seeing the same amount of yourself. But what the other stuff you see in the mirror can look a little bit different. So for people who saw a different amount of yourself, what I'm going to do is I'm going to share a video. This is one I took. And we're going to look at it and then talk about it a little bit. So let me go here. And I'll share the screen. So it might be a little bit bumpy for you, but it seems like it works fairly well this way. So I'm just going to run it, and I'll run it like 2 times. Okay, run it one more time.
Okay. Mr. Wood, are those the brand new Yeezys?
The brand new
Yeah,
what?
those look like Yeezys.
Mr. Wood,
Yeah, those are the brand new Yeezys.
Bro?
I have no idea. It's just what I have.
You get them on Yeezy.com.
Those are fire.
Yeah. So first, from looking at video, did it look? So what are some things you noticed? Was I seeing the same amount of myself, different amounts of myself as it went along? So Danica?
It looked like you could see the exact same amount of yourself. Like it was like from mid torso all the way down, and then even as you move further, it was the same.
Yeah. Now, yeah, the mid torso is kind of where I got cut off. In the very first part of the frame, could you see my feet?
I only saw those Yeezys.
Well, no, you didn't even see the Yeezys yet. But if you look at the very beginning of it, there was like no feet in there. Here, I'll go back. You can see the Yeezys again. So go back there, you don't see the feet. It's only when I step this far away that you start to see my feet and I guess what you're calling the Yeezys there and the cute cat, which nobody notices. It very much disappoints me. So in the very first frame, the reason you don't see my feet, they're there, but there's a limit into how much you can see in terms of looking at one time. You have a range of view. And if you get really close to the mirror, the experiment starts giving you data that isn't really what you want because you can't see the whole mirror at once. But yeah, most people are right. You see the same amount of yourself at different distances, and you can see that with the cutoff point. Also, you can look at the video later if you want. If you look at where the EZs are, they're always at the same spot on the door as well. So I just want to kind of like look at that, make sure we're on the same page with kind of that first observation. So for the second experiment, on that one there, were there any questions about how you're supposed to do the second one? We're not going to go over what the results were actually. Were there any questions about how you take that data? So, Jonah.
It was like a little bit different. So I had my dad help me, and from my angle, like it looked like he was measuring from my feet to my head. No, from his angle, but like from my angle, it looked different. So, like I think you couldn't really get an exact measurement because it doesn't work.
Yeah, the tricky thing with this is what you have to do is you have to direct the person who's helping you to pick the spot where your head is and where your feet are. Because if they do it from where they see it, it's actually not going to get you good data. So if you did that, you may need to use somebody else's data in your group that ends up having good data, or redo it or do something like that. You have to kind of point out to the person, oh, my head is there. Put like a piece of tape, put your finger there, my feet are there, and then leave those spots. So it has to be from your own perspective. If you
My
don't do
feet were
that, you
so
get a little
hard. They were always at the same place.
Yeah.
Like you
So,
can't really do your feet because like they just look like they're on the ground.
yeah. Well, you can see the spot where your feet touch the ground. It depends on the mirror how difficult that is. So this is kind of a trickier physical one to do, but usually once people get it right, they get more consistent data. So I think we're in decent shape with where we are with doing that stuff with experiment. What I want to do now is basically go over some stuff that will help you with the second part, which is figuring out why you get the results from these two experiments that you get. So I'm going to jump back to the OneNote notes. And a couple of things is what I'm going to talk about today is actually, I'm going to go through it, but also the video that goes over the same thing. So we basically just did this page here, and the video with the cute cat is there as well. But then this page here, if I look at extra resources, I have a video that basically goes over the same stuff. So if you have trouble with it today, I'll answer some questions, but it may not, but if that doesn't get it, you can go back and look at the video as well. So also another thing that is true for me is my chat is not working when I share my screen. So if you have a question, either raise your hand or you can just talk and I will work on trying to answer your question. So what I have set up here is a guy with a top hat. The only reason for the top hat is it puts the top of his head far away from his eyes, which makes life easier here. Looking in a mirror. And one of the things we want you to do on the lab for explanation is make a drawing of basically if somebody's looking at themselves in the mirror, basically what are the rays of light doing? So kind of like we made drawings when we did shadow diagrams, we're now going to do this, and we did it with like the little chicken and the cow. We're going to do this for like seeing yourself. Now, when we did shadows, we were focusing most on the extent of the object. So like where you have the edge between shadow and not shadow. If you're looking at yourself in the mirror, you want to kind of think the same way. So the most important rays of light to look at are going to be at the top of my head and at the bottom of my feet. Now, if I'm drawing rays of light, what direction should they go? Should they go from the object to your eye, or should they go from the eye to the object? Just say it.
Isn't it from the mirror to the object?
Object to eye.
You want to always go to eye. So you're going to go from object to eye, and what are you going to hit in the middle? So it starts with the object, what's it going to bounce off of?
The mirror.
The mirror, and then go to your eye. So if I drew this for, say, my feet, so the feet are down here, it's going to go hit the mirror. What's going to be true about the angle when it hits the mirror?
It will be the same as the angle when it comes back.
Yeah. So I'm going to try estimate that in my drawing. It may not be perfect, but it'll get the general idea of what's going on here. I think about there. And then I'm going to bounce it and take it from here to his eyes. So that's close enough for government work there.
Wait, when we're doing a quiz on this, are we going to be, is it going to be like, are the arrows going to be like a part that's necessary to do, or can we just do lines?
You can do line. You should be able to put arrows. You know, you actually do want to put the arrow parts on it because that shows what direction the light is going. And when we label things with different parts, that will be important. So for example, just with this here, bouncing off a mirror, we talked about this last class or 2 classes ago. What do I call the ray that's down here? It's going from the object to the mirror. What's the name of that? You can look back in the notes if you need to.
Incident ray?
The ray of incident.
Yeah, so this is the ray of incidence. And what do I call this ray up here that's going into the eye?
Ray of reflection.
Yeah, and it's not here. I'm going to do it down here and bring it up. So I can do that for the bottom. I also can do that for the top. So go hit there. And then go back to here. And I won't label those because you get it kind of works the same way. So now I'm starting to make a diagram showing how the light's going from my feet and my head to my eye. I could do any other point on my body, but those other points aren't nearly as important as those points that we have here. And this will start giving you a setup to actually answer both questions in terms of why it works when you move farther away, you still see the same thing, and also how big you physically look in the mirror. So this drawing can be useful. Also, I want to put one other sort of ray on here, and that is the virtual ray. Can somebody remind me, when I say virtual ray, what is the virtual ray and where is it going to be? The name kind of gives it away. Is the virtual ray real or not?
No.
It's the one that goes past the mirror, right? And like into the next part.
Yeah, it's the one that goes past the mirror. So it's what your eye perceives the ray of incidence to be doing. So the ray of incidence, it's bouncing off the mirror, but your eye doesn't see it bounce, so it thinks that the incident ray, no, you changed it color. Let me go, see if I can do this. Should be going like this. If I go down there, about like that. Let me fix it. Oh, come on. There we go. So the incident ray is physically in the mirror. Or not incident ray, the virtual ray. And because this is what your eye perceives the ray of light doing, it's not what it actually is doing. We call it virtual because it's inside the mirror, it's not really there. I could do the same thing up here. And notice that my virtual ray, which way does the arrow go? Does it go towards or away from the mirror?
Towards.
Yeah, it goes towards the mirror. And the length of this should be the same length as the ray of incidences. I may not have it exactly right, but it's about right. And then over here is going to be my image of the top hat dude, which I can't draw nearly as well, but that's good enough. So this is going to be the image. So part of what you're going to be doing is using this, because this kind of drawing here is a very important tool that helps you understand how to answer the questions. And that's what you're going to spend the rest of class working on. So what we're going to do is we're going to put you guys into breakout sessions of probably around 3 people each. And you want to do 2 things. First, go over the data from the lab, what you got last time. We already talked about the first question, you're all in agreement on that. But go over the second question and deal with any disagreements you may have. Then, once you have that done, then you're going to talk as a group and come up to answers to those various questions. So what I want you to finish up with the lab is, in your conclusions, is basically for each answer, explain and give evidence of, like, why does it work that way? So why do you see the same amount of yourself every time that you are looking in the mirror? So we go back to the Yahoo Mirror Lab. So I have that here. You're now doing this last page here. And you're going to need to make a drawing of you in the mirror, sketch the rays of light. We just kind of showed you how to do that. Then use that to explain your results in experiments 1 and 2. This is not necessarily an easy thing, and that's why we're giving you like half an hour to work through it and figure it out. So talk to each other, try to find patterns. It's okay if what you find isn't right. We're going to talk about this some more next class and make sure everybody's on the same page of it. But this is like looking at the situation, looking at your drawing to use it to explain what you're seeing in the real world.
Mr. Wood.
Hi, Mr. Wood.
I have a question.
Yeah.
Okay, let me share my screen so that I can show you. Okay. This is, can you see? Oh, wait, no, I didn't press share.
There you go.
Okay.
Okay.
This is what I drew.
So that's 2 people 2 different distances away, right?
But it's the same person.
Okay, yeah.
And I think that the reason that it change it, that you see more of yourself when you back away, is because the light rays are longer, and like this one is longer, so then that means the way it goes back is longer, and then you see like this much of you. Oh wait, you can't see my finger. You see this much of you.
Yeah. So I think you're getting into the right ideas, but you have the drawing, you're not quite drawing the lines to the right places.
What do you mean?
They're not really going to their feet or the eyes, Phoebe. They look like long arms.
The line should end up in the eyes. And you want to basically go like from the feet, bounce off, go to the eye at equal angle. You did a pretty good job of equal angles of the purple lines.
But is my conclusion what's right?
Well, Phoebe, you have to do it with the
I think you have to get the drawing right. And what would help with that is to go back to the first.
Did I erase it?
Yeah, erase the green.
Can you
just the green? Okay.
Oh, just the green.
Okay.
No, actually, I think erase the various lines, but keep the 2 people. Now, just draw a line from the yellow person's foot to the mirror, and then bounce it up to like the
yellow person's foot to the mirror.
Yeah. And then go from there to the middle of a person's head. We'll say that's where the eyes are. There's like
middle of the person's head.
Yeah. And the angle's about the same. So that's pretty good. If you wanted to, you could move where they junction down a little bit, but that's basically the right idea.
Mm-hmm.
Now go to this person, do the same thing with that person.
Okay. Let's add this. And then.
And go to the same spot. Yeah, go there.
And then
do the other one.
Add this from there to the eye.
Yeah.
Okay.
And so do you see how kind of there's a narrower triangle inside a wider triangle?
Yes.
And if you had it drawn perfectly, yeah, that's how it would look basically, because what you're saying is the angle on the outside here, I tried to draw on your screen and I can't, but the angle on the outside of the one that's closer, it's a smaller angle, but those are identical. And then the other one has a bigger angle, but again, those 2 angles are identical.